All right, how's everybody doing tonight? Everybody get a chance to get the pin in? We're going to be going, do what?
I've got it memorized.
You got it memorized? Okay, I'll go and put it on the board there while we're getting started here. We're going to be covering the chapter content for chapter 2 tonight and going right into the really long 13-minute video on IP data packet traffic, and that's going to be your lab tonight. Next week we're doing a lab on pinging. After our discussion, it'll be a little bit longer, and then the following week, week 5, we're doing it on the Cat 5 straight crossover cable. We'll be here till roughly around 10 o'clock that night. So tonight not too long, next week a little longer, and week 5 just plan on bringing a snack or something maybe for that night. Now remember, just to give you a heads up on the cabling lab, for those of you that have done this before, you're going to do it again, and you're going to help the row that you're in. The whole row cannot leave until everybody's finished in that row, so you need to stay for moral support. You'll start with a crossover cable and then go to a straight cable. And so if you get done quickly, which some of you will, on the crossover you go right to straight cable, and then you can be there for moral support for the rest of the folks in your row. Okay? And so just heads up, 2 weeks from tonight on that. We will be hitting the lab that night immediately when you come in. All the tools will be on the table, the cables will be cut, papers will be handed out to you, the color schemes for the cabling. I'll walk you through a real quick 5-10 minute tour of how to do it, and then go for it. During that session, you can walk out, take a break if you need to, because some of you might, come back, keep working on it till you're done. And by the time you're finished with the lab, you will have succeeded for sure with a crossover cable. But if you get that one done, you can go on and create a straight cable. Okay, and we'll learn more about what both of those cables do in the networking environment. You'll be using them quite a bit as a network admin. And it's good to know how to create them, even though you might not go into this as a career in cabling, which there is a good career in cabling, by the way. If you're interested in it and you really love doing it and it's easy for you, you might think about going in that career, because not many people think it's that easy and can do it 8 hours a day, 7 days a week. So if you really love it, there is a career in cabling. And you might just like it enough to be able to do it when you need to, like me. But if you want to do it full time, there's definitely jobs out there that you can do this full time, just cabling, that's it, running cables in all buildings. So about every other semester we usually have a cabling patch panel course in Cisco, where they teach you how to do the patching of cables and using cabling, and how to set up a patch cable wall and patch panel, and you learn how to do all that. And so if you're interested in that, usually every other semester we have that. So let's go ahead and get started on what we're going to be doing tonight, as far as, or what's going to be due for assignments coming up before we get started. So in week 3, we're in chapter 2, and we're going to be covering review questions. As always, you'll be covering review questions, quiz, and then tonight's lab. If you could go ahead and do this for me, since we're not going to be here that long tonight, go ahead and submit in week 3 lab that you are here. That would expedite that and make sure you get that finished.
So what do we write in it? We write our name?
You just write your name in the title line and say in the message here and submit. Okay? Okay. Tonight we're going over network standards and OSI model. When you take a Network Plus exam, or even in Cisco networking exam for certification, you need to know what the OSI model is and what the acronym means, and what the specifics of the OSI model are. You'll learn about that tonight. And like I said, in the Network Plus exam, which talks about in the back of your book, and then also, if you're interested in that, let me know. I do have resources for students, free resources. In fact, I just got a test prep last semester. It was an $850 test prep software that I've already duplicated If you're interested in taking the Network Plus certification, this test preps you for that test. It takes about a 3-month time frame to prep for it, to get about an 85-90 percentile on the test prep, and then you can go get your Net Plus certification, which is a middle-of-the-road certification. It's not Microsoft, it's not Cisco, but students have gotten jobs with that certification. The certification costs about $150 to go take the test. And so if you're interested in that, let me know. I have resources for you that I can duplicate and give to you. Every semester I generally have about 5 to 10 students that are interested. So just see me before you leave tonight. I can get those duplicated for you. Yes?
Do they offer that test in the testing center?
They do not.
Like they do with Cisco?
No, they do not. Nope. No. There's locations I can give you if you're interested of where to take the Network Plus certification. In fact, there's locations online now that you can take them. You don't even have to be at a location anymore. In some areas, you have to have a proctor there, but you can take it online in certain areas and certain colleges. And so I think the unemployment office had it last semester. So Network Plus is a good certification, like I said, and it's a good middle range certification. And companies have hired students with that certification and then train them or pay for the training for Cisco or the Microsoft training that they might need. Okay, so see me after class on that if you're interested in that.
I just have a question on that.
Yep.
What all type of background do you need, or do you have to take other courses to take the certification test?
No, you have to take the test prep certification software, which goes through a test bed of software, questions, about 500 to 600 database questions. And then basically what it is, it's a progressive testing software, meaning if you hit well in areas and you do good in those areas, it bumps you to another area that you're weak in and hammers away at you until you're good at it. It's a simulation software that continually tests you, right. It tests you on your knowledge. If you don't know it, it helps you learn those areas you're weak in. It is not an intro test, and so it kind of covers what you're learning here plus kind of intermediate level networking essentials. And so, but the software covers all the bases. It does a really good job. So if you're interested, let me know. I'll definitely be able to give you a copy. So with the OSI model, we're also going to look at identifying organizations that set standards for networking. There are quasi-governmental organizations that do create all the standards for what we do in networking in the United States. Other countries can't talk for, but here in the U.S., there's tons of standards and tons of red tape to go through any type of legislation for any new technology, whether it be cell phone technology, whether it be hardware technology, whether it be Wi-Fi technology. People don't just think of creating it and it's out in the market and people start buying it. It has to go through these organizations we're going to talk about tonight before they're approved. It's kind of like the FDA of technology. We'll look at the purpose of the OSI model as it refers to networking and explain the difference and the functioning of the OSI model layer. So we'll also look at how each level of the OSI model works with each other, discussing the structures and purpose of the data packets and frames, and then the two types of addressing covered by the OSI model. So first is standards. You've heard of maybe the word standard when it comes to any business. Networking is the same. We have standards that we work by. They're documented agreements. Some of these standards are literally thousands of pages in length. They're very technical, very precise criteria. They stipulate design and they also stipulate technology and procedures. The standards are essentially in the networking world, and they're a wide variety of hardware, wide variety of software. And as you can imagine, with all the hundreds and thousands of different companies, each one of those companies has unique networking and software criteria that they have to meet to make money. And so it's about money, it's about jobs, it's about business. And so you can imagine the new technologies that come out of the U.S. generally come out of businesses that need it, build it, use it, and then sell it eventually to other companies to use. Okay? So everything that we use today in networking generally has come out of a need somewhere. It's not just, somebody decided to do it because they had enough time on the weekends to figure it out. Companies needed it, so they developed it, they patented it, then they used it for a few years, debugged it, whatever they need to do, then they take it to these standard committees, and then it becomes a standard, okay? Like all the Wi-Fi standards we have today, were in business-oriented and government-oriented businesses for years prior to us getting these standards. What I mean by that is when we had, Wi-Fi G level, or even go back further, B Wi-Fi. G was out for 2, 3, 4 years prior to being public in the governmental facilities and also in private sector markets for research and development. And the same goes with every technology you can think of. Standards also define minimum acceptable performance. It is not the ideal performance. Like in Windows Server, if you ever look at the specs for any Windows Server online at Microsoft's website, it gives you the minimal spec requirements for a server. Those aren't the ideal specs, they're the minimal specs. Okay? Same thing with every technology will give you a minimal spec requirement for this technology. And the reason they do that the reason these groups do that is so they do not pigeonhole any business or limit any business or any entity from being able to use this technology. You can use this technology with this minimal requirement, but it's not ideal. Does that make sense? So they set the bar pretty low on what the requirements are for that networking protocol or networking technology, and then they let businesses decide what they need and don't need as far as security or beefing up the application, beefing up the software. Many organizations oversee computer standards throughout the nation, throughout the world, and an example is the IEEE and ANSI. IEEE does have a student organization. It's IEEE.org, has a student chapter, and while you're in networking here, you can get in this organization at a discounted rate, and they have yearly conferences. They have resources for you, training resources. They have 2 or 3 conferences in Chicago a year where students go and they learn and they have challenges, and so it's a pretty neat thing. I've had a couple students go once every other semester. I'll have a couple students interested to get signed up and actually start doing stuff in that chapter. And again, you can go online and just sign up, and then they change the website all the time. And so I've given up on trying to give directions on the website, but the website is dynamically changed a lot, and so but usually for the better. And so they do have a lot of good resources for networking students. And then networking professionals' responsibility: be familiar with groups that set standards, especially if you're going to go into business as an owner, or even if you're just going to be a network administrator. You need to know what businesses or legislation or committees you have to go to lobby for new technology. An example would be here in Rockford. We recently received a fiber connection from Chicago that we've been lobbying for 3 years, to where we no longer, as of this semester, have to pay $1.5 million for our connection to Springfield, Illinois. And so that was lobbied for 3.5, 4 years from folks in Rockford and the surrounding school area. And by going to Springfield, by lobbying the folks there. And then understanding critical aspects of standards that are required by your own networks is your responsibility. And a network admin, and I've been it a number of times throughout my life, is continually learning, continually moving, continually growing and morphing and changing and being educated. I go to at least 2 to 3 trainings a year to be updated on new technology and networking, recertify if I need recertified in areas. So if you're wanting to feel that you learn something and then you're done, this probably isn't the field for you, because you're continually learning every year something new, and sometimes every month something new. Okay, it's constantly changing, growing, and morphing with the technology. And I know some of you are right up that alley. That doesn't bother you at all. And so, but some students, I tell them right up front, this is the way it is in networking. Not that the protocols change, because they don't. It's the methods of how these protocols are utilized, new technologies all the time, businesses wanting the best and the greatest of whatever's out there, and so is consumers. And so this is one field to where anything in technology, specifically networking, is growing really fast, really fast. Now, ANSI is one of the first ones we're going to talk about, the first one we're going to talk about. It's the American National Standard Institute. It has 1,000+ representatives from industry and governmental. It determines standards for electronic industry and other fields. And you might have caught that it's industry and government. Yeah, there's people that are engineers that are part of this, people that are programmers like myself that are part of it, network admins, you name it, are a part of this group along with governmental governmental folks. And then these requests, the ANSI requests voluntary compliance with standards, and they obtain ANSI approval that requires rigorous testing. And ANSI standards documents are always available online, which I know you'd love to read. Just kidding. All the white papers you'd ever want to read and never want to look at again are on the ANSI website. Just Google ANSI, you'll find it there. EIA, the Electronic Industries Alliance. This is a trade organization represented from the U.S. Manufacturing firms. So this is heavily entrenched in Rockford, as you can imagine, being a manufacturing hub. It sets standards for members. It helps write ANSI standards, and it lobbies for favorable computer electronic industry legislation. The EIA and TIA. The TIA is a telecommunication industry formed in '88. It was a subgroup merged with former United States Telecommunications Supply Association. And the focus of TIA is standards for information technology, wireless, satellite, fiber optic, and telephone equipment. The TIA and EIA 568B series is a guidelines for networking cable. In fact, the night we do our cabling lab, you will see this name on your cable. All cables have this name on them and what standard. And the name I'm talking about is a TIA, EIA standard, and then whatever standard that code is, or whatever standard that Ethernet code is that you're using, that cable that you're using. IEEE, I already talked about a little bit, just promotes development, education, a great group. I was involved for a few years when I first started Rock Valley, but have not been involved for probably about 4 years now. But I do keep up on their website. I still get their literature and their magazines and know folks that are, and they are very big on student education and networking, and very beneficial to students to get while you're here to take advantage of it. They host symposiums throughout the nation and even the world. They have conferences, chapter meetings. They maintain a standards board, and the IEEE technical papers and standards are also on the IEEE.org website. And then ISO, it's the international standard for networking, International Organization for Standardization. These folks are in Geneva, Switzerland, is the headquarters. They have a collection of 57 countries. The goal of the ISO is to establish international technology standards across the board for free information like internet connection, Wi-Fi hotspots. You might have heard of WiMAX in global areas, in rural areas, and widespread authority the ISO does. And so I had a cousin that worked in Iraq for 4 or 5 tours, and he helped set up schools, plus he helped set up some of the Wi-Fi connections for the local hotspots for the kids and the parents and the community to connect to. And this group was actually the one that helped them and funded a lot of what they did, and had all the technology that they needed to do it with. And so big organization, international, but they want to get Wi-Fi in remote areas of where there's nothing basically, and to get connected and get people online and get technology where maybe it never been before. So it's a pretty cool organization. ITU, International Telecommunication Union. These guys specialize in, they're a branch of the United Nations, and they regulate international telecommunication. They provide developing countries with technical expertise. They do work closely, by the way, with ISO. They were founded in 1865, joined the UN in 47, and they have members of 191 countries. The focus here is global telecommunications and worldwide internet service implementation. They're more of a big umbrella, kind of a vision to get the word out to the UN and all the other countries, and they actually do work very closely with the ISO group. ISOC is an internet society founded in '92, professional membership society that establishes technical internet standards. Current ISOC concerns are rapid internet growth, keeping internet accessible, information security, stable internet addressing services, because in fear by 2025 we'll be running out of internet addresses from the slew of internet domains being bought up, and each domain having to have its own IP address. And so the increase of just normal consumers buying domains to businesses buying domains is heavily increasing on a month-to-month basis. And so this group is part of the IPv6 technology you might have heard of, and it's in all new computers. We had IPv4 for years, which was the IP technology for what we talk on the network with. But now we have IP6, which gives us a more range of numbers to work with on that technology, and this is a group that actually helped head that up. They oversee groups with specific missions, like the Internet Architecture Board. They have a lot of advisory groups that oversee internet design and management. Another subgroup of these guys is the Internet Engineering Task Force. They set internet system communication standards, particularly operational interaction. And anyone may submit proposals to this group, and they have a very elaborate review, testing, and approval process. In fact, all of these have a pretty elaborate testing and approval process. Then, IP, you might have heard of that. That is the Internet Protocol address. It's kind of like your social security number or your address at home. Every computer has its own IP address on a network, both internal and external. Every web server has its own unique IP address. When you type in anybody's domain, that's a unique IP address for that server to work on. And if you think about, do I know?
What do you mean by internal and external?
Well, if I hosted, for instance, in here, we all have our own internal IP addresses that I cannot access from outside the building. They're internal only. You'll learn this semester the differences. There are differences. There are IP addresses that are internal IP only, ranges, right? And then there are IP addresses that are made for external. Okay, but as you can imagine, with the slew of folks buying up domains, the decrease or the increase of the numbers getting shorter and shorter of the pool is much higher because of that. And so this group helps with that address management part of it. Though IANA, the Internet Assigned Numbers Authority, they have registries that started in 1997. And if you know anything about domains, you might not. I'll just explain it real quick. When you go to buy a domain, a website, you have to buy it through some registry. That domain, whether it be GoDaddy or registrar.com or domains.com or something. But all of these folks I just talked about talk and are managed by these guys. Okay, they oversee these groups and make sure the numbers, what the numbers are, how far are we from reaching the end of the number pool. And then the Asia Pacific Network Information Center and the Razoo IP Europeans, RIPE, is the other one, started in '97. Focus on IP management. And then in the late '90s, ICANN, the Internet Corporate for Assigned Names and Numbers, kind of branched off. It was originally governmental. Now it's more privatized, kind of like Fannie Mae and Freddie Mac. And so they are now kind of privatized, and they are private nonprofit. They remain responsible for IP addressing and domain name management. Like I said, every domain name from Google to Yahoo to MSN to your local business as a website has its own IP address, and these are the folks that oversee all of that. They also perform system administration, and users and businesses obtain IP addresses from ISPs, and some of the ones I already mentioned, and there's other ones out there as well besides the ones I mentioned. And so, OSI model, let's talk about that. OSI model, I'll just tell you up front, it's a philosophical model. It has nothing to do with hardware or software. You can't tie it down to any hardware and software, really. And so I'm going to let you know that up front as a disclaimer. But it is a philosophical model that does help networking folks understand where things fit in. Okay, where things fit in. And this model helps them do that on a communication level. And you'll see why in just a second when we get more slides down the way. So it's a model for understanding and developing networking computer-to-computer technologies. It was developed by ISO in the 80s, early 80s. It divides the network communication into 7 layers: physical, data link, network, transport, session, presentation, and application.
Programmers don't like salty,
Programmers don't like.
to
do
throw
not
away
throw
salty
away-
pretzels.
Right.
Yeah, exactly. Programmers do not throw away salty pretzels. That's a good one. There's a Pamela Anderson one I won't share it with you, though. I won't share that one with you. But there's a lot of acronyms out there, by the way. Just whatever
The
you...
one don't throw away sausage piece.
There you go, yeah. Mine's not probably good to mention, so I won't mention it.
I'll just stick with the book.
Oh, no, I won't tell it to you. So the OSI model, the first is the protocol interaction, which is a layer directly below, above and below. Then you go into the application layer, which interacts with software. Then the physical layer, which acts on the actual cables that are in your NIC card, connected to your NIC card, and the protocols that are connected there. The OSI model is a theory, theoretical representation describing network communication between 2 nodes. We'll look at some nodes here in a second. Hardware and software independent. Every network communication process is representative. It has what's called PDUs, which is protocol data units, is what is termed in the OSI model. It's a discrete amount of data, application layer function. It flows through layers 6, 5, 4, 3, 2, and 1. And it's a generalized model and sometimes imperfect. It's just a model. So here's an example. You've got 2 computers communicating, and you'll notice on the left computer, we'll start there and work our way to the right. On the left computer you have application, and I'm going to look at arrows later. Application, presentation, session, transport, network, data link, and physical. Flip your eyes to the right side, start at the bottom. Physical, data link, network, transport, session, presentation, application. Let me just explain it to you real easy in layman's term how it works. Let's use internet. Let's use internet terminology because that's a video you're going to watch tonight anyway. Let's use web. Give me your favorite web browser you use. Somebody. Chrome. Somebody say something different. Chrome. Does that sound good? Okay, so Chrome is on both computers on left and right, and they're on a website, and that website has an application running that they're communicating data with. Okay. It doesn't matter what the application is, but it's a website that has an application they're communicating data with. It could be text, it could be video, it could be voice, doesn't matter. It could be whatever. Okay, so it's an application, it's Chrome, and it's communicating. So, on the left side, the person that has Chrome running, they want to send something over here to the right side. We'll take the arrow on the left side down. We've got application layer, which talks to software. Software in this case would be what? Chrome would be the software, right? Below that, presentation layer, okay? We're taking the software, Chrome, that has whatever it is we're sending, and it's now packaging it into a presentation for the session and the transport and the network to carry that data. And that data could be voice, it could be video, it could be just text. Then into the data link layer, and then finally the physical layer. The data link and physical layer are getting to and are at your NIC card level. So you've got Chrome, you've got your NIC card, and so from application Chrome to physical layer NIC card, the OSI models traveled on that website sending whatever it is they're sending on the first computer. Make sense? Now travel to the right side. It's going up through the network medium. We'll say the network medium is Cat5 like we have in here. Cat5 from the box into the server room, and then from server to server we're going to be talking about fiber. But we're just going through whatever the network medium is here, going to the right side, going on the very right side, the arrow's going up. We're going into the physical layer. What's the physical layer?
The cables.
The cable. And then the cable's connected to the NIC card. The NIC card's connected to the motherboard. The motherboard's connected to the OS. The OS is connected to, yeah, the knee bone, the elbow bone. It's connected to Chrome finally. All right, so we go from physical layer to data link layer to network and transport layer. It's now getting ready to present it to the application layer, which is Chrome, and the user on the other end sees it. They see the message, they type back a reply, and the whole thing starts all over again. Okay? That's the OSI model. It's basically creating a layer, and the reason I rushed through the session transport network, those three layers that I just mentioned overlap a lot. Okay, those three layers, the session transport and network, because what that's doing is it's converting the data that might be whatever, video, analog, whatever, into binary. Computers only talk binary, okay? They only speak binary. And when it's pushing it out in through the Ethernet cord, through the network to the other computer, that's all binary language. So it's converting it, that session transport and network layer is converting it into binary to go into the data link and network layers to go to the other side, okay? The session and presentation overlap a lot, okay? The session and presentation have overlap a lot because those actually either are taking it from the application to get ready to go to binary, or they're taking it from binary, getting ready to convert it to application, okay? And whatever the application might be. It could be, again, voice, video, text, as an example, or even picture. So that's the flow of the OSI model, and just know this tonight, they all overlap, some more than others. I will say, and I already did, the session transport and network layer overlap a lot, the data link and physical overlap a lot, and the application and presentation overlap a lot, just because the proximity that they're in. And you'll actually hear companies talk about, we are in the business of the data link physical layer of the OSI model. We are in that business. That's what we do. Okay, like for instance, Intel, 3Com. 3Com is the most popular NIC cards today probably. So they could say that they are in the business of the physical and data link layer of the OSI model. Okay, folks that manufacture software and conversion software could say they're in the application presentation type of business. And then most networking firms that deal with outsourcing networking and fixed networks deal with the presentation or the session transport network and data link layer area. Because that's what they work in, that's what they set up, that's what they fix, that's what they come in and work in. So the top 7th layer of the OSI model is the application layer. So I gave you my terminology of everything. The book's getting ready to give you theirs now. So the top layer is OSI, is an application. It is no software application, but it is kind of. It does work with applications. It gets ready to push it to the applications, but it isn't a software. It's a model. Protocol functions are, it facilitates between software applications and lower level network services. Network interprets application request. Application interprets data sent from the network. Okay, that's application layer. Software applications negotiate with application layer protocols on such things like formatting, procedural things, security, synchronization, and other requirements. Data storage. Then presentation layer. Protocols on this one, it accepts the application layer data that was sent to it. It formats it. It's understandable to different applications and hosts. Example would be like text encoding. Every text on the web or that you send to anybody has an encoding, whether it be PDF, whether it be RTF, whether it be TXT, whether it be HTML, whether it be DOCX, it doesn't matter. In the header of that file has a encoding that it needs to be interpreted by the computer when it's going through these layers. And so an example here it gives is text encoding. The presentation layer protocols perform coding and compression. An example is a presentation layer services manages data and encryption. So before I get to session, let me go back. Well, I'll just talk about it real quick on encryption. Say you're communicating on Chrome with your bank here in Rockford, and you go through these 7 layers of the OSI model through the internet to the bank. You want to make sure that data is secure, right? And so the layer here before this, the application layer, preps for that security, whether it be encryption, which a lot of times it will be when we're talking about banks, SSI, certificates of authority, to where your data is safe and it's funneling through a tunnel to get there. So now we go to the session layer. Protocols here, coordinates and maintains communication between 2 nodes. The session, connections for ongoing data between the 2 parties. So this whole layer keeps the connection alive while it's going, while it's moving. The connection between the remote client and access server is an example. Connection between a web server client or web browser client and a web server. You're on Chrome, you're connected to your bank account here in Rockford at Harris Bank or something. You want to make sure that connection stays live. It stays live in the session layer. Now, does anybody ever remember dial-up modems?
Oh, yeah.
The screeching sound of dial-up modems. I kind of miss that, but anyway. You remember when you would connect and then it would squeal and then it would finally authenticate and you would be online, right? That whole layer, what we're talking about, the squealing and connecting, the sound till that connection time is right here in the session layer. And then once it's connected, finally, it stays in the session layer, all right, and stays connected until you do what? Till you disconnect. Till you log off the website today, till you log off the service, till you log off the bank account. It stays connected. That session stays connected with the session layer. Now, session layer also establishes and keep alive communication links, as already mentioned, for whatever session duration that might be. Let's talk about Eagle. You're familiar with that, RBC Eagle. If you go home tonight, log in and go make a cup of coffee, take a nap for 30 minutes, what's going to happen when you come back to your Eagle account?
It's closed down.
It's going to be timed out, right? It's going to be over, right? And so that's a session duration that Eagle sets in, whatever that might be. I've heard everything from, well, what is it? The session duration in Eagle? Do you know?
It's kind of arbitrary because it resets on time, but I've seen it time people out as soon as 15 minutes.
15 minutes. So we can say without.
But it's weird because sometimes I can walk away for an hour.
Oh, really? And come back?
Yeah.
Okay, that is weird. Okay, so we're saying that there is a time of some type though, that it does have a duration. It also on this session layer keeps, and by the way, if you didn't know, Alex works in RBC Eagle, so if you need any help with, no, I'm just kidding. I've never said that before, have I?
No, it's okay. No, I pretty much live over there. If you call him Monday through Wednesday, you're calling me. So.
Yes, yeah, he's a guy. I've had him in number class. I've actually never put him on a carpet like that. So this layer also synchronizes dialogues between 2 nodes, determines if communications ended, kind of like when you disconnect, you hit end communication on a button. You say I remember back in the dial-up days, you would go down to the taskbar, right-click, and literally say disconnect, and it would disconnect that connection. and terminate that connection. We don't hear those words today much though today. I mean, we don't hear terminate, we don't hear, we might hear end the session, but we don't hear that much anymore. Everything's on all the time, right? Literally everything's on all the time. Your internet's on all the time, your cell phone's on all the time, the Wi-Fi's on all the time. Is anything ever disconnected? No, it really isn't. Maybe for a few minutes, maybe, I'm guessing, but we literally don't hear, we don't even think about this session layer here, this termination connection. We don't live there anymore in technology. But we used to when I grew up, back in the olden days, we had things we would disconnect. We don't disconnect much anymore. I'm not necessarily upset by that. That's just the way it is. And it is kind of nice though to know that, when you go to your computer, you don't have to worry. It's on, or your phone, it's on. It's Wi-Fi's on, and so we are connected. And this is the area that keeps us connected to this session layer. So yeah.
I remember back in the 70s when I was going to Lake Junior College and I was taking a computer course, and I had my own monitor and stuff at home, and I had to have dial-up modem and stuff there to dial into the school.
Right.
The school's computer was shut down at a certain time, and I didn't realize it.
Right.
A couple of times there was messages saying, yeah, a couple minutes left, but I didn't realize what it meant, so I just kept going away. I'm banging away 12 o'clock at night, and here the damn thing was already shut down at the school stuff. The guy came in the next day and says, who the hell was on the damn computer? Got my system messed up a little.
Yeah. When I first started here at Rock Valley, all the faculty dialed in to the campus to connect to the network to get files and things like that. And they just killed that modem last semester. There was one faculty still holding on and using it. It was one modem in the top of some rack in IT department that they finally said, we're killing it. And it was over.
They built a little pine coffin to put it in.
Yeah, I don't know. Yeah, that would have been kind of interesting to see. They probably deserved keeping that one. Yeah, they've been on it all that time because literally it was still at like 56K baud modem. It was screaming slow, and they did it to connect to Eagle to EdNet we had that, and then Eagle now we have that. It was just crazy, but yeah. So yeah, I used to do that too. Would connect in through the college, and then I think before I got here, they actually would let the students at one time dial in as well for certain classes, and they could connect. Now I think that's a good idea. We'll get to this another time, but we are going to be bringing on campus that capability to where students in networking and Cisco classes can be able to log in via web interface and get on your computer that you work here on campus on in a virtual environment. And so that'll be kind of cool. But it'll be much faster than 56K baud. Much faster.
Doing that though, you dialed in, and you finally got the connection, you had to put in another code just to be able to complete the connection.
Yes, yeah, and if you didn't do it fast enough, then it killed it. Yep.
Even though you had it and you had your phone in there on that modem and it come up on the screen, you still had to put in another code to take in
Right.
to the computer itself.
Yeah,
And
yeah.
That's what the computers was twice the size of this room.
Yep.
The tape reels and.
Yep. And if you didn't type it in fast enough, it would disconnect. Thanks for sharing that. Transport layer continued here on to the layering. We went from session now, we're into transport. It accepts the data from the session layer. The session layer's handed it off to transport. It manages the end-to-end data delivery. It handles the flow control. It's connection-oriented protocols on this one that has things that establish connection before transmitting data. The checksum that checks to make sure that what is sent actually is received. And it further ensures data integrity. Connectionless protocols as well here. They do not establish connection with any other node. They make no effort to ensure data or it's free of errors, and more efficient than connection-oriented protocol because they don't have those rules attached to it. And so anytime you have rules attached to protocols, you have more chances of that protocol failing because those rules can be broken or those rules cannot be met. And so this is a connection list where protocols, and by the way, IP, the IP itself that we'll learn more about this semester, falls into this connectionless protocol. And IP by itself, and you'll hear about that in the video that we're going to watch here in a second. Segmentation is another thing on transport. What it does here in this one is it breaks up, say you have a video, a large video, this is a good example of that. You send it across the network. This is a part of the transport layer that breaks up that video into smaller chunks to be able to make it to its destination, and then it packages it all together again in this segmentation on the transport layer. It increases data efficiency, and it breaks it up accordingly to the network and the speed of the network. MTU is a maximum transmission unit. What it means basically is the largest chunk of data that can go across the network at any time. Ethernet is 1,500 bytes, which basically we have today in Ethernet technology, gigabit technology, to where we have the ability to send through Ethernet cords through Cat5. We can send gigabit speeds. It reassembles, a process of reconstructing that data segment. I always like to use the analogy of a train and caboose, of all the little cars behind it. It breaks up that data and then puts it back together again on the other side after it's broken that data up. And it puts it back together in the order, the sequencing order that it should be in, from 0 to whatever in that data train. So we have here a long message sent from sender on the left to receiver on the right. Notice in the long message, it breaks up that message into little blocks across the network, brings it back over to the receiver, takes those blocks and puts it back in the reassembly order in the order that it was sent to it. And so that's a crude example, but that's technically what the transport layer does. It just breaks the data apart to make sure that the data gets in a timely manner. This is just a screenshot of a real header file in a data packet. And this header file tells us a couple of things. One thing it tells us is the port, the source port, the destination port, sequencing number, and source port for the internet's always going to be 80. Destination port 1958. You'll see that a lot of times when you're going to a website, you're on port 80, or you're going to a website that's on port 80 and it's downloading to your computer, the destination. You'll see a lot of times in that header file, it'll be port 1958 will be the port, the destination port for HTML traffic, or it's called web browser or HTTP traffic, uses this port. The sequencing number is just a number that it tags the header file. And then a couple of these other things I want to make mention because it has a lot to do with dial-up. Notice the flags from congestion down to finished, and it has different numbers attached to them. In dial-up technology, whenever it would dial up, they had different sounds it would make. And also if it was trying to reconnect, it would also, or had congestion, it would also make different sounds. Today what we have, if you look, except for the back row, if you look at behind you on your NIC cards, the lights on your NIC card now have these same type of flags. They don't have as many. They have a yellow, green light, and that's it. That's blinking for activity. But it is in this area that occurs on the network. This is a file that actually tells it as it's coming through the Ethernet cord what the flags are. As it's coming to you, it's saying, oh, it's congested. As it's coming to you, it's urgent. As it's coming to you, it's been reset and we're resending the packet again. And so these are all just flags set up inside the data packet for the network protocols to determine if the data is made there successfully. Yes?
Is there a way to find your port 80 on the computer? Because I was trying to do that today. Because I was trying to open up XAM, and it said that port 80 was in use. And I made sure Safari was closed, you know, everything was closed and.
No,
it's
port 80 is
set.
going to basically be used by some other web service, like in Windows 7 and Windows 7 and Windows 8 has a service called Windows Server.
Well, it was a Mac, so,
Okay, on a Mac, it'd probably be Apache, the only one I could think of that would be using port 80.
well, I was trying to open Apache,
Okay,
and it said that port 80 was in use.
yep. And I can, after class, I can give you a command that you can type in your Mac to determine what's being used in
Okay,
that, in
'cause I
that
was
port.
going through all this thing, seeing what was open.
Yep.
I couldn't figure it out.
Yeah, I can give you a command. It'll tell you exactly what's being used, what's using that port.
Okay,
Yep.
great,
And I'll give you a command, plus I'll show you a GUI interface on the Mac that you can go to figure that out as well,
Okay.
to figure out what ports are being used. So the network, and then we go right into network layer, transport, and then right into the network layer here. We just left transport, we're now to network. The protocols here is it transports or translates a network address into physical counterparts. It decides on this network layer how to route the data from sender to receiver. Addressing is a system for assigning unique numbers to the network devices. Every device on your network has a unique network ID that the network gives it. And types of addressing for nodes are network addresses, as I mentioned already, and then logical addresses. And some of those logical addresses are addresses where basically either the device has been given the address or it's been coded in upon setup. Packet information, it's a transport layer segment is appended here. Routing, where is it going? What path is it going on the network? Your routers or switches would be a better example. Your switches on the network fall into this category, the network layer, because they determine where packets are going, in what path, and in what order immediately. They know at all times where things are going to be, where things are going to go. Routers also can be configured to that actually look over the switches and look over all the protocols on who gets to see what, who can send what, determine passive traffic. And then routing considerations, you have such things like delivery priorities, network congestion determines routing, quality of service, and cost of alternative routes. But routers are definitely smart enough in the scheme of networks to determine exactly where data packets need to go to get there. Now, they might not get there the fastest, but they'll get there, okay? And that's the job of the router to do that. And in the video that I mentioned, there's a pretty cool part where it talks about that, how that works. Then the common network layer protocol, which I've mentioned this already, is the IP, the Internet Protocol. This is the one the video calls the Wild Wild West, the IP. Because the IP basically is an open connectionless protocol, and you do have such a thing called the transport control protocol that wraps the IP. It's a wrapper around the IP that gives the rules for that IP of where the data flows, how it should flow, where it's going, source and destination, checksums, making sure the data gets there. But IP in and of itself is just wild and open and connectionless. Then in the network layer, the last is fragmentation. The network layer protocol, IP subdivides a transport layer into smaller packets. And so even in this, it breaks it up into bite-sized packets in the network layer, the data where it needs to go. The only thing I need to show you on this one is source and destination at the bottom. Because we're going to get to the time to live, we'll actually talk about next week when we do the ping lab. We'll do a ping lab next week and we'll show you what that means. But focus tonight though on the source and destination, meaning going back to the computer model earlier on the slide, you had your source computer A and B sending something back and forth. There's a source IP address and a destination IP address. That's found in the IP packet as well, of where things are going that it's sending it. Then the data link layer functions here is basically to divide the data received into distinct frames, getting ready to go into the physical layer. And the structured packet is now moved in, and it's raw data, sender and receiver's information's in there, error checking's in there, control information's in there, all in the packet frame. not all the information has been received. Maybe you have a partial mishap. That's why error checking's here. It'll basically just resend for that IP again to get the data it needs. Because packets do drop on a network, might be congestion, might be a switch failure, whatever. They are trying to be resent and rerouted again. Now, possible glut of communication could also occur, and what this would do would allow the NIC to process data without error, and that's because of the data link layer. The data link layer controls data as it's coming into the NIC card, regardless how much data is coming through. In fact, your computers right now, even though you're not doing anything on them, are busy right now on the network. They are busy. The switches know where they're at. They know exactly what health you're at on your computer at all times. There's two data link layers, sublayers. You have the logical link and the MAC link. The MAC link is a block hexadecimal ID. It's 6-character sequence by the vendor, like the vendor would be Intel, 3Com. And what we're talking about here is a NIC card. The NIC card has its own unique MAC address built into it, kind of like a VIN of your vehicle. And it's first part of the VIN, generally in a vehicle anyway, used to be anyway, the manufacturer or where it was built, possibly. Maybe it's built in Detroit, and then that would be part of the VIN number, the plant number. Well, in network cards, it's still the vendor is a 6-character sequence unique to the vendor. That's a block ID. Then you have a device ID, which is a 6-character number added at the vendor's factory, and that's generally a random or a pseudo random number that they generate. MAC addresses frequently are depicted in hexadecimal. If you were to do an IP config right now on your computer, an IP config all on your computer, it would show you your MAC address that is on your NIC card and what's been addressed, what's been planted there from factory. And that's all. That information is also sent across the network. So we have here the data link layer, which basically has split up into two layers. You've got your network layer and your physical layer. The network layer is the interface that the network flows upon. Okay, routers, switches, hubs, protocols, names of devices, network names. And then you've got the media access control, the MAC address. That is your NIC card that it's connecting to. Okay, that's the NIC card you're connecting to, and that data is being flowed through from those two areas, from the routers and switches through your Cat5 cable. That would actually be on the top part of the network layer. Okay, bottom layer is the actual NIC card where everything's connected. That's how the data gets to the computer. Use the data link layer. Here's a screenshot of a NIC card, and you will be uninstalling and reinstalling a NIC card on old computers this semester because you have a lot of room to do them in these older computers. The newer computers, you don't have so much room. But they are pretty easy, actually, though, to do. I know Gateway computer I did a while back, you don't need a screwdriver or anything anymore to replace anything on computers anymore. They usually have plastic switches, flips, Velcro maybe, really easy to take hard drives out, memory out, replace NIC cards, whatever. Make it a lot nicer than what it used to be. And the one I really like is at Gateway, which used to be here in town, but they used to order online, I believe. But I like their devices, their hardware. Dell's good too on theirs as far as replacing, being able to do it yourself, not too difficult to do. But you'll be replacing a NIC card. You'll notice though, on this NIC card, it has a unique number right up here at the top, and that's the MAC address. Okay? That's the MAC address, which again, partly vendor, partly random number to make it up. And then finally, physical layer, and we're going to end on this before we go to sleep. I see some eyes closing. Okay, physical layer is the last layer. It accepts the frames in the data link layer, generates signals as it changes the voltage of the NIC card. Copper transmission, meaning signals are issued, some voltage go through the lines on Ethernet, not much. It's not going to shock you or anything, but there's some voltage to go through there. Fiber optic has light pulses that go through to transmit data in the physical layer. And then wireless, Wi-Fi, is over the air through electromagnetic wireless waves. The physical layer protocols are responsible when receiving data to detect the signals, pass data to the data link layer, set data transmission rate, monitor data rate errors, error checking. Device operating the physical layer would be hubs and repeaters, NIC cards, all at the physical layer. I'm going to end there. Okay, so that's the OSI model, and the value of the OSI model is just a model to determine where things fall on the network, from server to router to switch to hubs to your media that's traveling across the network, whether it be Cat5, wireless, fiber, to your NIC card, all the way to your application layer of your computer. Now, it's much more complex than that, but that's an overview of OSI model, and the model in and of itself has been around since the early 80s. About the time that Windows 3.1 was being developed, still wasn't out yet, but being developed, and the first Mac was out, I believe then, is when this protocol came out, the OSI model came out for both Mac and Windows and Linux networks. It works for all three. Doesn't really matter. It's a protocol that is not tied to any network operating system. Okay? Yes?
So what was the protocol being used when Windows 95 and 98?
This protocol here.
The same one?
Oh yeah. Yep. It's been around a long time. It's not really a protocol. It's just a model. It's an OSI model to determine, okay, if we're having problems on our network, in this model, where's it falling at? Is it hardware? Is it my NIC card? Is it on the actual hardware level? Is it on the application level? Meaning, is it the computer and my software and my protocols there? Or is it the network that's bringing it? So it's depending upon the area, and it could be a number of these put together that's causing the problem. It's just a way to troubleshoot network problems with a model, if that makes sense. And so again, it's just a model, and it's not tied to any hardware. In fact, everything you read on OSI, for some reason they really hammer away, oh, by the way, this has nothing to do with software. Just like on that one slide, it said, this has nothing to do with software. Then in that very next bullet it said, but it works with software and getting, it's just, for some reason, it's a model. It's just a model, and so just know that. And so you're not going to see it tied to any software, any vendor. But vendors do use it. They do use it and say, we focus on this area of the OSI model. We're specialists in the application layer and the session layer of the OSI model, or something like that. Or if they're cable creators, cable developers for a Cat5 cable or fiber, they might say that they're in the networking area of the hardware, because that's where it falls in, and the media of the OSI model. So again, it's just a model, but it is something you need to know, especially if you're going to go and to take any test whatsoever in the future. You're going to need to know the OSI model and each one of the terms and what they fall in, and the protocols that they touch and how they overlap. But again, if you're interested on any exam, Network Plus exam, just see me right before you leave, because after we're through with the video tonight, we are done tonight. Next week, though, we will be staying longer because of the ping lab. Then week after, week 5, we'll be starting the lab as soon as you come to class. I will have everybody's grades updated by tomorrow, so check your inbox. I'll send everybody an email when they're finally submitted. Apologize for not having them submitted already to you. Been kind of a crazy week, but anyway, I'll email you tomorrow when those are all submitted. But after the video, and please don't go to sleep, it is only 13 minutes in length. So let me go ahead and get it started, and we'll be done.
So the grades that's showing online is not a packet.
Do I know?
The grades that's showing under the resource tab is not accurate.
Well, I graded some week 1 stuff already, but week 2's not been graded yet.
Okay.
Some of you guys have already turned in stuff for week 2 already. Yeah, and so if you have, I've not graded those yet. That's what I meant. Week 1 I've already graded, but week 2, I try to have week 2's graded by earlier than this, so.
Well,